Okay, let's look at the subsequent part here, which we are told to actually find the area here, the bounded area here, and asked to be expressed in the form. Let me just write it down in this form here. So this area in this form here, we need to show that the area enclosed for the above is actually from theta 1 to theta 2 and a square, 4 sine square theta minus 6 sine theta, sine 2 theta plus 2 sine square theta. Okay, so I'm just gonna write this down here. Plus 2 sine square 2 theta. Okay, great. Before we start, I think what we should do is just find the boundary here in terms of a. So for this case here, when theta is equals to pi, we know x is equals to a 2 cos pi. Pi is 180 cosine 2 pi. Pi 180 would render it to be minus 1. Then 2 pi will just be, so this would just be a 2 times negative 1, so it's negative 2 minus 1. Okay, so this is negative 3a. So this point here actually is important. This point here, which corresponds to pi, is actually negative 3a. Maybe I just put negative 3a like that. Okay, so this is okay. Then after which this part here is actually theta. Okay, just remember that that's a corresponding point. After which you have got theta equals to 0. So x is equals to a 2 cosine 0 minus cosine 0 here. Cosine 0 is 1. So this will just render as a. Okay, so check your calculator here. This is a. So this one has got okay, it has two values here, but you will talk about that later. So this is 0 or 2 pi. Okay. Now, usually what I tell my students to do is actually to take note of how the pi changes, because you know that pi starts from 0 here and it just increased to pi on the other side here. So in order for you to visualize it properly, what you need to do is actually, if you look at the p here, you start off with 0 here, and because your p parameter is from 0 to 2 pi, it will go one full circle. So here's about 2 pi, right? So the question now is, how do you actually find the area enclosed above circle? One thing that students will typically take note is because there's this bump here, which is quite annoying, right? Okay, this bump here, which is very, very annoying. I understand, but let me tell you that actually the parametric equation would actually what do you call it? It will actually settle it itself. Okay, so this point here, if you want to find out, what we do is essentially by writing in the Cartesian form. Okay, so I'm just gonna let this point here be parallel to the y-axis. I'm gonna show you how this is being done. So let point K be point on C such that tangent is parallel to y-axis. I actually don't really need to know. I just need to show you that actually it will be a continuous curve, and theta equals to theta equals to theta k. Okay, just says it's theta k. I don't care. I just basically want to show that this is k, and let's say this is xk and this is yk. Actually, you don't really need the yk, but okay, I'll just let it be like that. This point here. Now, if you want to find the area under the graph, area enclosed. Okay, so students will say, how come? So what we need to do is actually from minus 3a to k, meaning we get the area under this graph, right? Including this side here, right? So this part here is important. So I'm actually taking, maybe I should just draw out the area. I'm taking this area here. Okay, then this is the area here, minus off the bottom small area here, the small bump there. So that small bump there would just be this small bump here. Okay, what you eventually get is actually this bump here. So the area enclosed will just be from integral of negative 3a. This is what you do, right? You start with 3a here to end with xk, right? So I'm just going to end with xk, which corresponds to theta k. So this is y dx. That's okay. Then after which I will just start with the bottom one will be a to x. So this is a, to xk over there. So this is xk. Okay, this is xk, okay? Is y dx over here. Great. So once this is done, what we're going to do next is actually just try and just minus 3a xk here, y dx. So we know that if this minus xorb plus xka y dx, okay? And this could actually combine, because minus 3 to xka, you can actually combine them. And in secondary school, we get it. Actually, we don't really need a k there. We will just settle everything by itself, which is the amazing thing. Minus 3a to a. Yeah. So, yeah, that's how we do it. Then what you do is actually you just change it to the parametric form, right? So parametric form would mean that we would make y just sub y and so on, and just try and find. So this part here, parametric form, remember this point here, a corresponds to theta. It should be from theta because you're starting from here to here, okay? So it should from theta equals to 0. Then this part here, because we are looking, remember this is 0 to 2 pi, okay? So your starting point is important. A is actually theta equals to 0. This corresponding parameter is theta equals to pi. Remember that. So y would be, I'm just going to copy the values down. So this part here would just be pi, and this is 0. And y would be a 2 sine theta minus sine 2 theta. Then you need dx, we're just going to differentiate x here. So dx dt, d theta will be a negative 2 sine theta plus 2 sine 2 theta. Yeah, and after which we're just going to bring that down. Let me just copy it down. Dx a minus 2 sine theta plus 2 sine 2 theta. Sine theta plus 2 sine 2 theta, and this is d theta. Okay, great. So minus sine theta plus 2 sine 2 theta d theta. Yeah, there you go. So once done, I'm just gonna group the a together, and this is pi. 0 is a square. This is minus 4 sine square theta plus 4 sine theta sine 2 theta. Minus plus 2 sine theta. Just expand it, and this would just be minus 2 sine square 2 theta d theta. Okay? So once this is done, we are more or less there, because now take note of what they ask you to show. They want it to be in a positive 4 here. So what we're going to do is actually just extract the negative out and flip the sign top and bottom, right? So this is pi 0 a square. This is 4. A lot of things are right. A lot of things. So sine. Then this is plus. Minus, sorry. This is minus. 2 sine square theta. 2 theta. D theta. Yeah. And I'm just going to flip it up and down. Pi 0 a square. This is how you do this question here proficiently. If you have questions or comments, please let us know. I do know that this question here is a bit difficult if you are considering the harm there. But just take note that actually the parametric equation, if you integrate from here to here, it will just find the enclosed area. Okay, so that's one way to know, but if you are not too sure, you could actually work it out like that. Yeah,